Hello, welcome back. This is part 3 in the series. We were discussing how to reduce parasitic loads from a golf cart style contactor. This is a standard 400 amp generic Chinese product. I think it came from Electric Car Parts Company in Utah a couple of years ago. In one of the first videos I tested this. The current draw on the coil is over 300 milliamps. So when you add that up, it's a lot of kilowatt hours that go to waste. So just a quick recap. This is a 12 volt shell dual coil latching contactor with a controller, and then we have this 24 volt midnight solar remote trip product with a controller. And since the last video I did do a design spark 2-piece case. It's really rough looking. I just went with a kind of the lowest cost 3D printing option for proof of concept. I just wanted to do this to have a couple mounting holes to make it easier to use. This could be easily done with a finish, although even these two pieces are about $85, so it's not cheap. I guess it costs less than having a $50,000 mold made for the tooling for injection molded pieces, but for a one-off it's a little pricey. So I'm pretty excited. This is what I've been waiting for. This is an AMETEK 48 volt coil. This is a latching contactor and a control board. It came out pretty nice because it's simple. There's no voltage regulator on the PCB. I just have a couple of 48 volt mechanical relays. The main capacitor is a timing capacitor for the secondary relay, an LED, a couple of diodes, and a couple of resistors. Very simple process. And it's on. I'm using the switch again to simulate power being fed through the BMS. And in a situation where you've got an out of range temperature, voltage, current, when the relay opens in the BMS, little delay. I chose a 100 microfarad timing capacitor for the secondary relay. I think it's a little too big. It discharges through the primary relay and causes a delay. I'm going to cut that down to a 56 microfarad. And then this is version 3.1. I have a version 4.0 that is going to eliminate this delay. But again, this circuit board is not designed to take the place of an overcurrent protection device like a fuse or a circuit breaker. It's intended to be used in conjunction with the BMS and a relay to protect the battery only in an extreme situation where it's super cold or one of the cells drops too low, as a protective device only. So just for demonstration purposes, went ahead and hooked up the positive wire going through the BMS, through the ammeter, into the control board, and then into the latching contactor. So we've made quite an improvement in the parasitic load. We'll turn it on. We get a good current pulse, and we're down to 3-4 milliamps. Very, very low. I'll take that compared to 300. And just to keep me honest, this has a photo relay on it. It's a type of solid state relay versus the switch. This would be typical of many BMSs that use an external contactor. I'm going to use ice water to simulate a cold condition. Yeah, as I said, a little bit of a delay there. I will mention I've got a version 4.0 that, as I said, I've cleaned this up a little bit, changed the diodes to a glass bead type diode, and put a blocking circuit in to eliminate the delay. I haven't tested that. It should work fine, but again, this isn't intended to replace a circuit breaker, so as far as I'm concerned, I'd use this the way it is. The newer version does have a bypass resistor on it, or bleed down resistor I should call it, and it will consume about 1 milliamp in addition to what we're seeing. So like I said, I don't mind a little delay. I'm just going to reduce the size of this timing cap and everything should be fine. I do have a single piece 3D printed model ready to go. I haven't sent it out for fabrication yet. It just, again, it makes it a little bit easier to mount the circuit board by having something to put it on. This got mounting holes in it that you can screw right into a backboard or something like that. Now, one last item. I didn't talk pricing. I apologize for that. This is a 400 amp rated device. You see it's pretty much identical to the standard Chinese version. This company is in New York. This product was assembled in Mexico. It was $192. It's a little bit pricey. But if you need 400 amps, this is the one. I've ordered a DuraCool product. It's rated for 300 amps, similar to this one, which is rated at 300. Those contactors, the latching contactors, a single coil design like this. They have one version with just the studs, and then another version which I really like. It's got bus bars on it with 2 holes on each side, so you could actually connect 2 batteries together in parallel right on the contactor, and you wouldn't need a separate bus bar, so that would save you some money. The DuraCool product, again, there's a long delay time on everything, waiting for it. I expect it'll work with the same PCB controller. It has the same coil specs, plus or minus a little bit. It's much less expensive. The actual price of the contactor is $65. Unfortunately, with the tariffs and with shipping, I don't know why it was so high. I ended up having to pay $125 each for those. But that, I guess that'll be part 4. When that comes in, I will test it, and by then I'm hoping I've got version 4.0 that we can test, and I'm going to have a 3D printed one-piece base made up, and we'll do that in a couple of weeks.